In this session, we'll try to understand the Docker components. Those are required to make a Docker environment functional. The first and most important component is the Docker node itself. So what is the Docker node? Docker node is the compute system that has its own dedicated CPU, memory, storage along with operating system running on top of it. Operating system can be from your choice. It can be Windows, Linux or Mac OS or any OS that you want to, any flavor of Linux that you want to use. Then the first and most important component that needs to be installed on this system to convert a normal system into Dockerized system is Docker daemon. What is Docker daemon? Docker daemon is the main program that runs on top of the host to make it container ready and manages all the container related components like container network, container image and containers, etc. Then the second component is the Docker client, because installing Docker daemon converts the normal node into Dockerized node, but still we need some sort of user interface to manage the functions of the Docker daemon. And in that case, we need a special application which is called Docker client that provides a CLI based user interface to control the functions and operations of the Docker daemon. The moment Docker client is installed, it is going to be integrated with the Docker daemon so that we can control the functions of the Docker. And the next component is Docker registry. Docker registry is an image repository from where the Docker daemon is going to pull the images to run the containers, like Docker Hub. There are many other registries also, but here we are going to use Docker Hub registry because that is provided by the Docker itself, Docker community itself. The advantage of having Docker Hub registry is whatever images that we are going to build, we can store these images in the Docker registry so that we can share those images with multiple other environments or operators without repeating the process of creating Docker images again and again. Then the next component is Docker image. Docker image is the master object that will be used by the Docker daemon to run containers. An image can be considered as a ready-to-use system which contains lightweight kernel, application and static configurations. Next component is container itself. Now we can use those images to run the containers and as a microcompute instance or microservices. Now let's try to understand the Docker operations. In order to utilize the Dockerized environment, we need to perform multiple operations and functions. Let's try to understand all those operations and functions here. The first and most important function that is required an operator to work is Docker file. A Docker file that contains the detailed information about the Docker image, starting from core OS to packages, applications, and configurations. That means the Docker file is going to be the source of truth for all the components and configurations that are defined in a Docker image. Then the Docker build operation. Docker build operation is a process or a command that is used to create Docker image from the information that is defined in the Docker file. And then later, same images are going to be stored in the Docker Hub registry and later it is going to be consumed by the operators to run as the container. Then the Docker push operations. By default, when the images are built, these images are locally stored on the dev system. Now, in order to make it accessible to other environments and other operators, we need to push these images to the Docker Hub registry so that it can be shared among the multiple environments with appropriate privilege to pull the images. Then the next operation is Docker run operation that is used to run the container with the help of Docker images. That means whatever images that we built and pushed in the Docker Hub registry are locally stored in the system itself. Now it is the time to run those images as a container so that we can start or utilize the services of it. So we are going to utilize the Docker run operation or Docker run function to run the containers on the Dockerized node. Next is Docker pull operation, a process or command that is used to pull the images from Docker registry to the local system before Docker daemon can use the images as the container. Because without pulling the images locally, because in order to run the containers, image must be locally present in the system. That's why pull operation is going to be used. Now let's try to understand a working architecture and operations of the Docker in detail, so that we can correlate this environment with the actual production environment. In the actual production environment, the Dockerized environment is divided into two sections. So on the left side you can see it is dev environment. On the right side we have created prod environment, because it is going to be exactly same in your real world environment also. On the left side we are going to have two types of team members, which is developers and DevOps. Developers are the group of users who has ability to develop the applications. On the other hand, DevOps are the group of operators or users who has ability to understand the application's code along with the understanding of the infra component. These group of users, DevOps group of users, are going to work as a bridge between the developer and the infra, and they are going to help the applications run as a microservice in the Dockerized environment. For that purpose, what they are going to do is they are going to first write a Docker file. And as we discussed, Docker file is the source of truth that contains all the information that needs to be created or defined in the Docker image. Once the Docker file is written, these developers are going to access this Docker CLI to control the functions or to manage the functions of the Docker daemon. After getting access to Docker CLI, they are going to perform Docker build operation. And this Docker build operation is going to take the input or information from the Docker file and going to create a Docker image. When the images are built, by default those images are locally stored in the dev environment or dev node. To make these images available to the prod environment, we need to push those images to the Docker Hub registry, which is a centralized repository. For that purpose, again DevOps team members are going to perform Docker push operation, which is a command that is going to take all these images defined by the name from the local system and going to push to the Docker Hub registry. Once this is done, now these images can be used on the prod side to run these images as the container. For that purpose, we are having another team which is called DevOps or SRE, depending on the name or the organizational structure that is being followed. So these are the group of users which are going to manage the nodes, Dockerized node for the prod environment. Now, so prod team is going to perform the Docker run operations. That means they want one of these images to be used to run the containers. The moment they are executing the Docker run command followed by the image that they want to use to be used as a container image, this Docker CLI is going to pass these instructions to Docker daemon. This Docker daemon is going to validate whether the image is locally stored or not. If the image is locally stored, it is going to use this image and launch the container on top of the Docker daemon. But let's assume if this image is not locally stored, then we first need to bring or download these images from the Docker Hub registry to the local system. So there are two ways of doing it. One is the proactive pull or the reactive pull. What is proactive pull? Just because we are aware that my other images are not locally stored, we can perform Docker pull operation manually to pull these images and store it to the local system. Or there is another pull which is automatically triggered by the Docker daemon on behalf of the Docker run operation. Let's say on the first time when DevOps or SRE team executed the Docker run command followed by the image name which is Nginx. So this image was locally stored, and that's why Docker daemon was able to find it and it has created the containers. And this image we had pulled before running the Docker run operations by using Docker pull operations. Now the next scenario is DevOps and SREs are going to perform Docker run operations for, let's say, Python and SQL images. Now just because these images are not locally stored, Docker daemon is going to invoke Docker pull operation on behalf of the Docker run operation that was executed by the DevOps or SRE team. This Docker pull operation is going to pull the images from Docker Hub registry to the local system and then run as a container. We can perform these entire functions and operations manually, or we can deploy the chains of tools and techniques to automate this entire process for effective and efficient operations. To do so, we need to divide our Dockerized environment into dev and prod. The processes performed on the dev side are called CI or continuous integration, and the processes performed on the prod side are called CD or continuous deployments. When the chain of tools and techniques are deployed to automate this entire process, it is called CI/CD pipeline. So that's all for the day. Now let's try to quickly recap what all the things that we discussed in today's session. The first thing is the containers and dockers in general or in non-IT terms. Then we talked about containers and dockers in IT infrastructure. Followed by the evolution of compute technologies, we tried to understand how the compute technologies evolved from the physical compute, normal compute nodes to virtualized and then Dockerized environment. Then we talked about Docker component followed by the Docker operations and an working architecture. That's all for the day. Hope you enjoyed watching. If you find it useful, please encourage us with your comments, likes, shares and subscriptions. Thanks for joining. Stay tuned for more videos.